Hey guys, so we're finally starting our last unit, chapter 11, which is on transformations. And it's probably something you've done at least a little bit before. So we're starting with 11.1, where we're going to kind of remind you about what congruence transformations are, and then do translations. So a transformation is just an operation that maps a pre-image onto a new figure called the image. So the pre-image is what we call the original figure, and the image is what we would call the figure after transformation. So if you have a transformation that preserves length and angle measure, that would be called a rigid motion. Sometimes it's also called an isometry or a congruence transformation. And congruence transformation is really, I think, one of the more common ones. Rigid motion is pretty common too. So in a congruence transformation, the position of your shape may change, but the images remain congruent. And that's kind of the most important part here. So if it's one of the transformations we're working with, that only works if the figures stay congruent to each other. So they may change position, but they should not change shape or size at all. So the three types of rigid motions, or congruence transformations, are translation, reflection, and rotation. So kind of a reminder of what these are. Translation is where all you're doing is you're moving the figure in some direction. So it always moves each point, goes the same distance and same direction, and that's where you get your new figure here. So this would be the pre-image, and this would be the image here. And we can tell by these little markings here, which we'll talk about later. So reflection, it works like it would in a mirror, but people often think of this as a flip. So you've taken this arrow and you've reflected it over the y-axis here. So each point on the image and the pre-image are the same distance from the line that it is reflected across. And then a rotation, you just turn the image around a fixed point. So if this were your fixed point, you've taken this image here and rotated it around that point to some degree. So it goes through a specific angle and a specific direction, and then each point is the same distance from the center. So this point here is just as far away from the center as this point here. And when you combine two or more transformations, you call the result a composition, or a composition of transformations. So let's practice a little bit just looking at some pictures and trying to identify what type of transformation is going on there. So maybe pause and think about which ones these are and see if you can identify the type of transformation. So the first one, if I look at it, yep, they are the same shape, and all that's going on is that this one is being moved along and is ending up over here. So this would be a translation. Then if I look at this one, it has moved, but it didn't stay the same way it was. It's not oriented the same way. It's pretty clear that this has been rotated going that way, right? So it's been kind of flipped over, rotated onto its side. So this one would be a rotation. And then this third one, if we look at it, it's basically this top one and bottom one are mirror images of each other, and they're pointing the same distance from this x-axis here. So this one is a reflection. All right, now last one is kind of interesting because this one actually could be any of them depending on how you look at it. So clearly it could be a translation, right, if you were to just move it from here to over here. So that's one possibility. Or you could look at it as a reflection across this diagonal here. So this would be just like reflected across that way. So that's also a possibility. But you also could get this by rotating this square. If you were to rotate this square 180 degrees, it would end up over there. So it really could be any one of those, and there's not a way, based on the information we have, to tell which specific one it is. Because again, any of those would give you that image. So let's specifically talk about translations now. So the key features of a translation is that the image is the same distance and same direction from the pre-image. So you can see right here in this diagram, so this blue one is the pre-image and this red one is the image, and the way we can tell are by these markings like I mentioned. So when we do the image points, we mark them with this little apostrophe, and it's read as prime. So that's what it's talking about down here, prime notation. So this would be A prime, B prime, C prime. And you can see that, looking at these lines, each point is the exact same distance and direction from its pre-image point. And one of the ways transformations are sometimes described is that you're moving each pre-image point along a vector to get to the image point. So a vector is just a quantity that has both direction and magnitude or length. So here's an example picture of a vector, right? So it shows vector PQ. It's written this. It looks kind of like array, only instead of doing the arrow except instead of doing the full arrow like that, we just do the top part of that. So that's the symbol that we would use to indicate a vector. And this one goes 5 units right, 3 units up. So this right here is the vector PQ. And the way you would write this vector in component form, which is just showing its horizontal and vertical components, is 5, 3, and then we use these kind of arrow-shaped parenthesis-looking things. So one of the most common ways you'll see transformations written or described is what your book calls a translation rule. So we write it in coordinate notation. So basically it will look something like this. So it shows you x, y, goes to, and then it's x plus or minus some amount to indicate how far it's moved left or right, and y plus or minus some amount to indicate how far it's moved up and down. Because if you were to move a point to the right, you're increasing the x value of that point. If you were to move a point, say, up, the y value would increase. So, as our little example here, if you were to move a point 8 units right and 4 units down, then you would write this in that coordinate rule as xy goes to x plus 8, y minus 4, because you'd be moving 8 to the right, which would increase your x value by 8, right? If you were at 2, and you go 8 to the right, you'd be at 10. So that's how you write that. So we're going to take a minute and just kind of practice going between the different forms of how we can write these, and you could pause it and try it on your own first before we check it together here. Right, so let's look at this one. So our words say we're moving 2 units left and 5 units up. So if we're moving left, then the x value is going to be decreasing, right? 0, -1, -2, and so on. So when we're moving left, then we're going to be subtracting. So x would go to x minus 2, because that's how far you're moving left. And if we're moving up, that means the y value is increasing. So up is the positive direction. So this would be y plus 5. And then for the component form, it's basically just this, but without the x and y. So the component form, it would be moved along the vector -2, 5. So the vector that goes 2 to the left horizontally and 5 up vertically. So let's look at this next one then. So y goes to x plus 2, y. Right, so remember x indicates the horizontal direction. If I'm moving plus 2, that means I'm going in the positive direction. So this would be going 2 units right. And then if I look at what's going on with the y goes to y. So actually nothing's happening in the vertical direction. So it's just a translation 2 units to the right. And then for the component form, your horizontal is moving by 2, but your vertical is not changing. So it'd be 2, 0. Right, third one down. So now we're given the component form, -1, -3. So this would be going -1 that way, and would have a vertical of -3. So this would be a translation of 1 unit left, because we're going in the negative x direction, and 3 units down, because we're going negative in the y direction. And then xy would go to x minus 1, y minus 3. So again, this is just basically you're just doing the x and y in front of whatever the component form is. And then last one here, we're moving 7 units down. So the horizontal direction isn't changing at all, so x just goes to x. And then if you're going down, that would be negative y direction. So x, y minus 7. And then the component form, your horizontal is not changing, so that would be 0. And then your vertical is going down 7. So your component form would be 0, 7. So I'm going to end this video here, and then we will move on to the other problems and finish up in the next video.